Next problem. A sample of 100 items drawn from a universe with mean value 64 and standard deviation 3 has a mean value 63.5. Is the difference in the means is significant, right? So what will be your inference if the sample had 200 items? So given a sample of 100 items, so sample size n is equal to 100, then has a mean value 63.5. so sample mean, that is 63.5, drawn from a universe means population mean is 64 and standard deviation 3, right? So population mean mu is equal to 64 and population standard deviation sigma equal to 3. So we are going to define the null hypothesis. So is there any significant difference? There is no significant difference. So the population mean is exactly 64. It is the sample is from the universe, the population with mean 64. We are assuming like that. Alternate hypothesis, so it is not equal. It is not from the population with mean 64. So there is a significant difference. So we are taking mu not equal to mu naught, that is two-tailed test, right? So significant levels. So let us have 5% and 1%, right? So first test statistics z is equal to x bar minus mu by sigma by root n. So that is equal to substituting the value 63.5 minus 64 by 3 by root of 100. So you will get minus 1.6667. So calculated value is modulus z. So modulus, take the modulus z. So it is 1.6667. Now tabulated value at 5% level 1.96 we know. So comparing, and for 1% level 2.58. Then we are going to conclusion. So comparing the calculated value and tabulated value. So first at 5% level, calculated value is less than the tabulated value. So 1.667 less than 1.96. So in this case, H naught is accepted. So in this case, H naught is accepted. That is, there is no significant difference between means. Then you are taking at 1% level. So calculated value 1.667 is definitely less than tabulated value 2.58. So in this case also H naught is accepted. So there is no significant difference, right? Suppose if the sample mean is 200, so we are going to check what will happen, right? Test statistics, we are calculating Z, substituting 63.5 minus 64 by 3 divided by root of n is 200, root of 200. So we will get minus 2.3574. So calculated value is modulus Z, that is equal to 2.3574. So now we are comparing the tabulated value. At 5% level, calculated value is definitely greater than 2.3574 is greater than 1.96. So H naught is rejected. So there is a significant difference. So next, in 1% level, so 2.3574, which is less than 2.58, right? So at 1% level, the hypothesis is accepted, right? There is no significant difference. Next problem, a sample of 400 individual. Sample of 400 individual means n, the size of the sample, equal to 400, is found to have a mean height of 67.47. So sample mean x bar, that is 67.47. Can it be reasonably regarded as a sample from a large population with mean height of 67.39? So population mean, that is they have given mu is equal to 67.39. and standard deviation, population standard deviation sigma is equal to 1.30. So we'll check whether this sample is reasonably regarded from the large population with mean 67.39. So first we are going to take there is no significant difference, that is the sample mean is reasonably regarded from the population mean 67.37. so it is from that population the sample, right? There is no significant difference between sample mean and population mean, right? That is our assumption H0, right? But let us see, right? Given sample mean, sample size n is equal to 400, mean 67.47, population mean 67.39, population standard deviation 1.30. Null hypothesis mu is equal to mu naught, there is no significant difference. Alternate hypothesis we are going to take two tail, mu naught equal to mu naught, there is a significant difference. So let the significant level, so they have not given, for you take standard right, or for the all problem if they have not given, take it as 5%, right? So tested statistics z is equal to x bar minus mu by sigma by root n, substitute the value 67.47 minus 67.39 by 1.3 by root of 400, so you will get 1.2308. So calculated value is 1.2308 and tabulated value at 5% level 1.96. So conclusion, calculated value is less than the tabulated value, therefore H0 is accepted. There is no significant difference between sample and the population mean. So it is reasonably regarded as a sample from a large population with mean height of 67.39 inches. That is the conclusion, and standard deviation 1.3. Thanks.